Good evening, everyone. I'm honored to introduce our distinguished speaker, Dr. Nisha Talagala. Dr. Talagala is the founder and CEO of Pyxeda, a Silicon Valley-based startup specializing in artificial intelligence and machine learning. Dr. Talagala did her PhD from University of California in Berkeley. She's then led technology teams at Intel and Fusion IO, and she was previously the co-founder of another AI/machine learning startup named Parallel, which was acquired by DataRobot. In addition, she chairs the Usenix conference on MLOps, the TEDx speaker, and she has written many articles on AI and machine learning for Forbes. Please join me in welcoming Dr. Nisha Talagala.
Thank you, Amit. Thank you, everyone. It's great to talk with you this evening. So I'm going to be talking with you guys about production machine learning, particularly the challenges of production machine learning that have been collectively called ML operations or MLOps. Some experiences that industry has had with it, and some innovations, as well as different things that you can do to bring these best practices or these learnings to your own professional life or to your business. So what we are going to cover in this talk is, first of all, what is production ML and what are the different areas that make up this ML ops? Then we'll talk about how these areas have evolved. ML ops is a fairly new idea in the industry. It's only about 2 or 3 years old, but even in those 2 or 3 years, it has made some fairly massive strides. And some of the topics have become more established, some have become, created new innovations, and some emerging areas are starting to become relevant. Since MLOps is a relatively large area, I'll give you guys a feel for what the different areas are, but we will do a little bit of a deep dive into two specific topics. First is how you combine MLOps and cloud computing and how you build full-scale machine learning solutions in the cloud itself. Then we'll talk also about a very particular problem in MLOps called drift, which has become very recently very relevant with COVID-19. Then we'll conclude by some comments about where MLOps is going, as well as some resources of where you can learn more about it. So first, let's talk about artificial intelligence tools. So what is this slide? This slide is filled with logos. And these logos, each one of these logos is a separate and independent product from just one of three companies. Each of these, like say this one, for example, this one that I'm hovering my mouse over is a product from Amazon called Sagemaker. This is a product from Amazon called Marketplace, and this is a product from Amazon called Recognition. The ones with these logos in them are from Google, and then they have others from Microsoft as well. So each of these is an artificial intelligence product from either Google, Amazon, or Microsoft, and they're all to solve part of the AI problem. So the first thing you can observe is that this is a lot of products. And this is, by the way, about a year old. And so this isn't even all the products that these three companies offer. It's probably easily a good 30 or 40 products short. So, and this does not include, other companies like IBM, SAP, Hitachi, Salesforce, open source products, products from other smaller companies. This is just from three companies. So the key point here is that there are a lot of AI related products out there for people to use to build different kinds of AIs. And there's more coming every single day. However, there isn't a lot of what I would call business adoption. So this is a business adoption chart from the United States. And what you can see is that even though the IT industry, which is the biggest bubble here, is doing decently well when it comes to using artificial intelligence inside, to solve business problems. Once you go off of that, it becomes a very small fraction very, very quickly. So if you look at other areas like consumer electronics or banking or automotive, the amount of artificial intelligence being actually adopted and used to solve business problems is still very, very small. And so on one hand, you have a really large number of products. On the other hand, you don't seem to have a lot of real business problems necessarily being solved just because there are so many such products. So now what we are going to talk about in this webinar is the gap, or at least one of the largest gaps, that is basically, preventing all of these tools from becoming good business results for companies. So what we are going to talk about is, what does it take to actually get an artificial intelligence to become useful for a business? And that is the life cycle that we've listed here. So let's go through this life cycle, as a case example, we'll go through, like, say, a bank that is trying to figure out which customers are going to leave the bank. And so this is a classic business problem called churn. And the idea is that you do not want a customer to leave. So you want to be able to use AI to detect which customer is going to leave before they do, so that you can prevent them from leaving. So let's look at, and that's one of many business problems out there. Let's look at that problem in the context of this life cycle. So the first thing is the business need. So we've just talked about that. The business need is to prevent customers from leaving, or very specifically, to identify customers who are going to leave. Okay, so now we go to, okay, now we know what the business problem is. What is the data? So in this case, the data is very likely to be historical information about customers. So you want to be able to teach the AI the difference between a customer that is going to leave and a customer that is going to stay, so that we can identify those who are likely to leave. So first thing we have to do is to gather up all of the data that we have. Then we use the data to develop an artificial intelligence model, or some kind of an AI algorithm that we use. And then we train that model and we try to see how good it is by using test data that is from our original data set. Once we have a model that we think is going to work, then we have to obviously use it for something. So the idea of putting a model to work is called deployment, or deploying the model. So the idea here is, at this point, we have an experiment that seems to have good results. Now we are going to put this experiment into production and actually try to use it to identify real world customers for the bank. So we have to basically get the model from the experiment into some program which we can use to essentially connect it to the business. So once this model is deployed in this manner, then the next thing to do is to connect it to the business. So in our case of our bank example, this might mean that the sales department of the bank, or the marketing department, or the customer service department of the bank now has a program that they can use maybe every day to figure out what customer is likely to leave. So connecting this AI to this program is part of making it production. So once it's in production, then, for example, a salesperson could every day see, okay, which customers are most likely to leave. They might then decide to call those customers. And then they will figure out whether or not the AI's prediction was good, because they'll be able to tell whether or not the call was worthwhile, at least to some extent. So once you've connected it to the business, then you will figure out how well it works, and then chances are you'll improve it. You may find that the original AI did not predict all that well. You might find later that you have more information about the customers, then you might want to retrain another model. And so this cycle repeats. So this is the cycle that is required, and typically multiple iterations of this cycle are required in order for the business problem to get solved. So one of the biggest reasons why all those tools from the previous case, all of these tools don't necessarily result in all of the expected adoption, is because this cycle is complicated, and each of the tools typically handles one or two stages of the cycle. And so a business still has to connect all the tools together into a cycle. They have to figure out what their business problem is. They have to figure out whether they solved it the first time around. If they didn't solve it, how to improve it, and then it goes on and on. And so you can see that this part requires machine learning and AI. This part requires some software engineering. This part probably requires operations to make sure that everything is running correctly. And so typically it requires knowledge of a number of different skills, and at the same time just a connection of a bunch of different tools. And so production machine learning is really about that. Typical machine learning focuses a lot on, how do I develop a good AI? How do I get a good metric out of that AI, like a good accuracy value? But the problem is that unless you actually put that into production, it doesn't really impact the business in a positive way. And so you can think of production ML as all of these steps that I'm highlighting on my mouse, plus a repeat and scaling of these tests that are traditionally done as experiments. So a typical workflow again, you define your use case or your business need, you prepare your data, you model, you train, you deploy, you integrate, you optimize and see how well it's working, and then you repeat. And so a typical machine learning operation has to run this life cycle at least once, but frequently over and over again. So one of the things that makes, companies like Facebook or LinkedIn or Google, who are really, really good at AI and machine learning, one of the things that makes them successful is that they're extraordinarily good at iterating. Some of these companies iterate as quickly as every 15 minutes. So if you think about a shopping website, for example, and if say that a new dress comes out, like a famous movie star wears a new dress, they don't want to wait too long to try to sell that dress because people are going to go and look for it immediately. So the iteration of this can be as frequent as every 15 minutes if you are looking very, very quickly to respond to new pieces of data that have come in. On the other hand, if you have industries like insurance or the stock market or banks, where you may actually have legal reasons why you can't just keep changing models, it can take as long as 6 months or a year to complete one of these cycles. And so therefore, everybody iterates, but how quickly they iterate sometimes has to do with how capable they are, and sometimes has to do with their industry itself. But the iteration is the key to getting a good business success out of an AI. So this brings us to this term of production machine learning. So MLOps is a term that became popularized about 3 years ago. I actually created the first Wikipedia page for MLOps when I was at Parallel M. And production ML, of course, is not just a few years old. Production ML has been done for many, many years in large web companies, and they're extremely good at it. Enterprises, on the other hand, did not have really production ML as an area. They kind of created things on their own here and there, had some things that worked, had some things that didn't work, and stuff like that. And so the first MLOps platform for enterprises was from Parallel M in 2018. And what it was really inspired by was the idea that other software, like databases as a perfect example, are very, very complicated pieces of software, but at the same time, everybody uses databases. And even though they're complicated, it's not like, there's a lot of database tools out there, nobody's running a database. And so why is that? One of the reasons why that is because how to use a database in production is something that has been defined. There's a job called a database administrator. They know how to do this. There are, institutions where they can go and learn how to do this, and they can get certified. And with that certification, they can get jobs and things like that. And so the training and the practice of production databases is so mature that even though databases as a software are very complicated, they are literally used everywhere. So MLOps is looking to do the same thing for machine learning, which is the idea that it's not just the tools. The idea is that the practice of production machine learning is something that you have to really think about. It's a combination of DevOps, software engineering, and AI. And without doing it, it's very hard to go from advanced algorithms to business successes. So that's what MLOps is. So what has MLOps become in the last 2 years? So the first part of MLOps was when it was originally formally kind of, thought about in 2018, involved a bunch of different areas. But the core idea was the same, which is you have advanced algorithms or, experiments that did well in the lab. How do you convert them into products that do well in the company? And, this was from an original article that I wrote some time back where we described that the MLOps arena has a bunch of different areas. So one of them is that the idea that anytime you have a new model, it has to be integrated into your business. You have to decide when to train it, when to retrain it, when you have new information, things like that. You have to convince yourself that it's working well, which is what we call ML health. You have to convince yourself that it is generating a positive impact for your business. So going back to our example of the bank churn, we have to be convinced that people who were going to leave the bank are now not going to leave it because they were identified early, maybe they were given a special deal or something like that. And so over time, the number of people leaving the bank should go down because we have early identified them. And so even if the AI is running and never crashing or anything like that, if it does not change the number of people who are leaving the bank, then it is not having business impact. Finally, in some areas, particularly when areas which have legal implications like healthcare, it's very, very important that you be able to answer questions about exactly how your model is working. And we'll get into this a little bit later as well, where we talk about model governance. So when we initially, started working on MLOps, these are the areas that we outlined. Now in 2020, MLOps has made some really massive strides. There are now tens of startup companies that are working on MLOps. There are MLOps products now, not just from DataRobot, the company that acquired Parallel-M, but also from mainstream companies like Amazon has some tooling, Microsoft has tooling, HP has tooling for MLOps, things like that. And so the idea of how to connect a model to an application is called deployment or serving. There's a lot of tools for that, and I'll go over one of them in a little bit. The idea of making sure that you can figure out what you're running and how to reproduce an experiment, how to containerize it, run it in the cloud, how to understand and respect emerging laws. These are some of the areas that MLOps in 2020 products are being built for and technologies are being developed. There are also many startups focusing on just health and diagnostics for machine learning, and then improving the life cycle and helping people iterate better. So we've talked a bit about the origin of machine learning operations and some of the different areas. Now we'll do a little bit of a deeper dive into two topics in MLOps, and particularly involving, first of all, end-to-end pipelines in the cloud. So now why are we talking about the cloud? So two reasons. One is that cloud computing is clearly an area that most businesses are moving to, if not at least considering moving to. It is a very convenient and practical way to build production systems at the same time, not spend more than you need to. And some of the most sophisticated artificial intelligence related tooling is already available in the cloud, either natively from the cloud vendors or simply as software that you can put into the cloud in a rented computer and run on them. So we'll start by looking at what does it mean to build a production machine learning solution, specifically in Amazon Web Services, which is right now the most used cloud platform in the world. So there are multiple sort of layers of tools and problems that you kind of need to connect together if you're trying to build a production machine learning solution in Amazon Web Services. Now, this stack is something I'll discuss in general, but it is not unique to AWS. It is true for pretty much all of the main cloud vendors. It just so happens that we'll discuss some specifics in the context of Amazon. So the first thing is, of course, the infrastructure. So this is where your software runs. So you can rent, compute from Amazon, you can rent storage from Amazon, you can rent log management services from Amazon. For example, you can basically, rent an Amazon instance. You can rent space on their simple storage service, which is called S3. You can monitor everything by subscribing to their log service, which is called CloudWatch. So at the base, you need compute to run on, and you can rent that compute. Now, in artificial intelligence, most of the time, you need to label the data. Now, we're not going to talk about labeling in a lot of depth today, but the basic idea is that for most types of artificial intelligence that are called supervised, the model and the algorithm cannot train if they don't know the right answer for their training data. So in our previous example, where we wanted to know if a customer was going to leave the bank, every customer record would need to be labeled with, did they leave the bank or not? So that would be considered labeling. So a lot of problems require labeling. Not all of them. Labeling is a hard problem, and therefore people definitely love it when they don't have to label, but a lot of things still need labeling. Then the data has to be prepared and cleaned and sometimes processed to make it ready to tune an AI. Then you have to do modeling and deployment, which is finding a good model and then putting that model into a program where your business can access it. Now, clouds also have what are called marketplaces. And a marketplace is a place where you can buy a model. Now, this has been around for quite some time. Hold on just a second. Yeah, so marketplaces have been around for quite some time. It's not entirely clear how often you can buy a good model that'll serve your purpose. Most people end up creating or tuning or training one because their problem is somehow unique, and therefore they can't just go off and buy something. But at the same time, there are marketplaces and there are places where you can buy and sell models. And so Amazon, for example, you can go and buy and sell AI models to do things. Service APIs are APIs that you can use to detect, to actually just, you don't have to build a model. It's just an API that will answer questions. So a simple example of an API in Amazon is an OCR reader. So if you have a document, for example, that is encoded in OCR, you don't have to build yourself an AI to read it and get text. Amazon has an API for that. So you just call that API, send it to your document, it will send you back some text. So if your problem is very, very generic and there isn't really anything specific about your version of the problem, a service API might work for you. If your problem is somehow just a little bit different, like your documents are very special and the regular generic thing doesn't seem to read it all that well, probably need to build a little one of your own. So these are some of the areas that you can think about getting production grade, services that you can run in the cloud. And you really, in order to create a production ML, you need to at least get some infrastructure. And then you have to figure out what subset of these things that you need. So very simply, if I'm getting an API, I don't really need any of these other things. I'm just going to call the API. If I buy something, I might still have to deploy it, but I probably don't have to do any of the training. If I'm building it from scratch, probably need to do most of these things. Now, keep in mind that building something from scratch does not mean that I am going to write the AI algorithm from scratch. It just means that most of the time I will take an existing algorithm and train it or tune it. So those are some of the things that you have to do when you do production machine learning in a cloud context. Now, I'm not going to go over this in a lot of detail, but just to give you a feel for how Amazon tools can be connected to build that same life cycle that we saw in the circle. You have an Amazon product called S3. You can put your data there. You can write your own programs to transform that data into whatever you need it to be. These programs are frequently written in Python. Once you've modified your data, you can put it back here into the S3 storage. Amazon has an AI product called Sagemaker, which you can use with this modified data to train an artificial intelligence model. Or if you wanted to, you could get a model from the marketplace and bring it into Sagemaker. You could also bring your own model into Sagemaker if you wanted to by writing it from scratch. Once you have the model and then you want to connect it to your business, Sagemaker has a product called Endpoint, which you can use to create a running program with an internet address in the cloud that is going to basically generate predictions from your artificial intelligence model. Once you have that, you can connect it to the outside world. And Postman is just a simple example of an application, but you can put any application you want here. So this is an example of how, in this case, 1, 2, 3, 4, 5, possibly 6 Amazon products can, as well as your own programs, can be connected to build that full end-to-end life cycle. So remember the data, we start with the data, we train the AI, we deploy the AI into a program, and then we connect it to our business app. So this is an example of a kind of life cycle that you can build in Amazon that you can use to convert an artificial intelligence experiment into essentially a production grade solution. So this is an example of how artificial intelligence production can be done in a cloud context like Amazon. Very similar concepts can be applied in Google Cloud or in Microsoft. The products are obviously not exactly the same, but the idea, storage, data preparation in a program, training in a program, deployment in a program, connecting it to the outside world through some kind of networking. All of this is, the cycle is the same. The tooling is obviously not the same at all because every cloud does this in a slightly different way. But this is a specific way that you can do it in the Amazon cloud. So that is one area of machine learning operations, which is really just how do you connect all this stuff together? Because in order to get something to become production and useful to your company, it clearly has to be connected to the end problem, and then it has to be able to be reconnected once you've decided to make it better, and then you keep going on and on. So the connectivity is a good chunk of the battle of just getting the stuff to work. And what we covered right now is an example of how you do that connectivity in Amazon Cloud, which is basically accessible relatively easily to most businesses at this point. The next area that we're going to talk about is what's called ML health and drift, which is really about, okay, so you've got one working now. Is it working well? Is it buggy? Has it broken? Can you even tell? So this is an important area, and it's also become increasingly important right now because of COVID-19. So why has this become, this particular area of ML ops become very important for COVID-19? So these are, by the way, a few different articles that you can find. And if you just go and, Google for maybe COVID-19 and drift, you will see a bunch of articles about how COVID-19 has broken AI. Now, the central problem that it has highlighted is not unique to COVID. It is actually a problem that has always been there. It's just that people knew about it, but not as many people knew about it before. And the central problem is that artificial intelligence learns from the past. Most of its job is to learn patterns. And where does it get its patterns? It gets its patterns from past data, which means that inherently it thinks that the future is going to be like the past. So if we go back to our example of bank churn, we believe that customers who left the bank in the past are going to have something in common with people who are leaving the bank later. So if we find, for example, that there's a common pattern to customers who have left the bank in the past, the AI will believe that future customers who have that pattern are also likely to leave. So that's a central assumption of how artificial intelligence learns. Now, what happens when that assumption is broken? What happens when the world changes in such a way that the new world doesn't look anything like the past world? One of the things that makes AI and machine learning so difficult to debug is that it does not break when this happens. It doesn't break in the classic sense that the program is not going to crash. It is not going to generate an error. It is simply going to generate a bad prediction. So it does break, but not in the way that we as programmers or computer scientists are used to having programs break. So drift is the notion that if the world that is in production changes and is unlike the world that the AI was trained on, the AI is going to generate bad predictions without even realizing it. Now that you understand that problem, it should be fairly clear why COVID created this problem. So because of COVID and because of the fact that so many businesses have shut down, that so many restaurants have shut down, all of us who might have gone to offices and ordered food are now basically trying to have food delivered to our homes, which essentially meant that the way that the machinery of the world worked changed very rapidly. So you can imagine that an artificial intelligence that was in the business of forecasting pretty much anything would break, because the way that resources are being consumed right now, the way that people are driving, the way that people are spending money, the way that, pretty much anything has happening is different from what it used to be in the past. And so this has created a massive case of drift. And so the idea now is that this is a production problem, because now you have AIs in production that are simply going to generate wrong predictions because the information they're getting is in no way resembling what they have seen in the past. So this problem, by the way, is not unique to COVID. It will happen anytime that an AI gets put into a situation where the data does not look like the training data. And you can imagine that these bad predictions can create so much trouble for a business that it will want to detect when situations have changed. So the idea of drift is that if the circumstances have changed, you want to be able to detect that, because then you want to really go back very quickly and figure out whether or not your model's predictions make sense, but maybe even having humans look at them, because the AI can no longer be trusted. So there are many different kinds of drift. And and we're not going to get into them in great depth, but the key thing to recognize is that something has changed. And the AI, since it believes so much in the past, is probably not going to predict correctly. Any number of things could have happened. For example, it's possible that the AI is now seeing a set of questions that it had never anticipated. It's possible that it's seeing questions that is not common, and also areas that it was never trained on. It's also possible that the questions are the same, but the answer is now different. So this for example, is fairly unique. For example, in the case of COVID, which is people still need food. It's just that they don't necessarily need it delivered to a restaurant at this point. They need it delivered to their homes, or possibly to their grocery stores, which can then deliver it to their homes. So a lot of things about drift have to do with something has changed in the environment, and then that change is going to somehow impact an AI. So there are techniques in machine learning production or in ML ops that are called drift detectors or drift generators. So this is an example of a drift test generator, where the idea is that if you have a certain training data, which is what the AI has learned from, it is possible to create testing sweeps that change this in some ways to see whether or not the AI's ability to predict is impacted. And so, since drift is a known real world problem, there are sort of two identifiers of it. One of them is that you have to be able to test and try to detect before the problem occurs. You can inject different kinds of fake drift into your system and try to figure out whether your AI is going to be robust. So you can, for example, detect these kinds of shifts by looking at the description of the incoming data. Has the incoming data changed? And things like that. We will not go into the technical depth of this, but the short version to think about is part of being, good production machine learning is being able to test very heavily, but test also circumstances that exist in production or could exist that are not necessarily what the AI has been used to. And there are some very technical ways in which you can do that as well. So these are basically some of the things that, that you can learn if you want to get really deep into production machine learning, is ways that you can detect different kinds of drift, because drift itself is actually a fairly sophisticated problem in its own right. So those hopefully give you some ideas of some of the things that, that people who want to create machine learning in production have to really start to learn in addition to the core machine learning. One of them is just simply, how do you build a thing? How do you actually just get a first working system for your business that is actually going to solve a problem? Then after that, how do you monitor it, take care of it, and also how do you debug it when it goes wrong? So the final thing we will talk about today is, different things that are emerging in the area of machine learning, as well as how to learn, machine learning ops. So a couple of the areas that we didn't cover so far that are becoming more and more important is, one area is what's called model governance. So the idea is that, as artificial intelligence becomes more prevalent, there are laws that are coming up around the world to try to control and manage how it behaves. So, just like pretty much any technology where the law is trying to catch up and the technology is, like blazing forward and the law is busily trying to figure out what's going on, just like that, these laws are coming up in all sorts of, ad hoc ways. So some of the laws, one of the biggest ones is in the European Union, and it is part of the GDPR, which is the General Data Protection Regulation. Now, the GDPR itself is not entirely about AI at all. It just contains a couple of clauses that have implications. And one of the clauses, one of the things that it says, for example, is that if a consumer information is used in order to build an AI, that consumer is entitled to an explanation of how their information is used in a prediction. So, depending on how you choose to interpret that law, there's a bunch of things you might need to do, like keep an eye on exactly how the information was used, try to track the history of how a model was trained. For example, if I'm a consumer and I come along and tell a bank, I want to know what you did with my data. And if the bank is legally required to tell me, then the bank is going to have to remember, were there any models trained with Nisha's data? What did the bank do with those models? Are they right now being used anywhere? If so, if they're being used, what are they being used for? All of that stuff has to be tracked if they intend to answer my question. Things like that. So for businesses, particularly businesses that are in risk averse areas like healthcare, finance, insurance, things like that, you have to be able to keep track of what's going on, because you pretty much have to be prepared for legal actions generated by consumers or by your industry. So governance is basically that. The idea of governance is that you know what you're doing, you can reproduce it if you need to, you can explain it if you need to, and this is very important in areas that have these kinds of legal implications. So some of these are coming from laws. Some laws, like the GDPR, are generic. There are some laws, for example, in the United States, there are specific laws that apply to financial trading that have been, by the way, true for a long time. And so they are one of the reasons why models that are put into production in financial trading typically take months, if not years, to put into production, because all of those laws require that everything be documented before you put a single model that affects, like, say, my retirement money, for example, is going to be affected by a new AI. There's lots of laws before that AI can even be put into production. So this is the model governance. And so what I typically tell people who are looking to learn machine learning ops is that model governance is something you can learn in a general way. And I'll talk about that in a little bit. But at the same time, it's also something that is so industry specific that it's important to learn whether it applies to your industry. Then we have model security. So like all software programs, AIs can be hacked. The more advanced the AI, the more likely it can be hacked. Simple AIs are harder to hack because they cannot be influenced one way or the other by anything. And this is becoming an important enough problem that major banking companies in the United States now have model security teams that have to validate every AI model before it goes into production. So again, the more sensitive your industry, the more likely. There have been practical, embarrassing examples of model hacking. For example, Microsoft had a chatbot called Tay, which was released that Twitter based, not Twitter the company, but Twitter users were basically able to retrain the bot and have it do some very embarrassing things, which then embarrassed Microsoft and things like that. And so model hacking can be anywhere from just embarrassing to essentially a massive legal or business problem for the company. This area is sufficiently early. Part of the reason why it's early is because there just aren't that many models out there yet. And so haven't been as many practical examples of hacking that people can think about. So the same way that drift existed for a long time before COVID made everybody realize that drift was a real problem, model security is a little bit like that. There haven't been as many hackings yet, but there will be. And when they become more visible, then it will become clearer to people what they need to do. And some companies who are very conservative, like banks, know that the impact is going to be serious enough that they've reacted before they've essentially had to react. So those are some of the other areas that you can be aware of when you're learning about machine learning ops. So the final thing I wanted to point out is that we, as in my company Pyxeda, has recently started an MLOps, or production full stack machine learning class in Sri Lanka. It's actually starting in about a week. And what it teaches people fundamentally is how to build a production machine learning solution in Amazon. And so all of those different areas that we talked about, how to use the storage, how to bring in data prep, how to train with SageMaker, how to use a container to bring in your own algorithm, how to actually create an AI, connect it to an app. We teach that entire cycle, hands-on, so that you can build your own production solution in Amazon. And then we also provide an overview of techniques like drift and techniques like governance so that you can have a feel for the kind of things that you might need to think about. But it's fundamentally a hands-on course for technical professionals that will show you how to build a real-world production AI, inside your own Amazon account. So that's a course. It's starting next week. This discount code is for SLASSCOM members only, and it will give a 15% off discount on the price of the course. So if you are interested in this is an email that you can reach out to, or you can call this number for the local Sri Lanka reps who can help you register for the course and get you more information as well. So in summary, what we talked about today is production machine learning. And what we covered is this idea that it's not just enough to have advanced machine learning algorithms. Like you may have taken a machine learning course in university, you may have learned all sorts of interesting algorithms. The problem is that that is not enough to create a solution that adds value to a business. In order to add value to a business, you have to be able to package up that algorithm, deploy it somewhere, connect it to the real world, tell how well it's doing, repeat it, improve it, and as well as deal with real world situations like governance and security and debugging that ultimately make the difference between whether or not your business is going to be able to make money out of this AI or not, and what kind of risk this AI will bring to your business. So generally that is called full stack end-to-end machine learning, where the idea is that you don't just know machine learning, you know what it takes to build a working production machine learning solution. Starts with just getting your model used, but it's also then the entire life cycle. This is starting to become seen in job descriptions. You might see that people are now looking for ML ops engineers, full stack data scientists, or applied ML engineers. Typically, if they're asking for one of these jobs, it means that they're trying to explain that they don't want you to just build an algorithm, they want you to make it work for something. And so that pretty much requires that you be able to understand the tools and concepts and the applied, kind of best practices of ML ops. And that's what we covered here today. So that is all that I had. So I'd be happy to take questions. So Nandula, do people know how to ask questions? Because I see one person with their hand raised. Should they be typing their question into the Q&A or into the chat?
I can get them to speak if that's okay with you.
Absolutely, yeah.
Yeah, okay.
Yes, if you guys have any questions, feel free to please speak directly or raise your hand and, Nandala.
Hello.
Yes, hi.
Hi, Nitya. How are you?
I'm doing well. How are you?
Yeah, well, I have a question. Like, once we complete the course with you all, are we allowed, do we receive the certificate from Amazon saying that we have completed? Or is
No,
it just from?
it will come. Yeah, the certificate will come from our organization, not from Amazon. But what we do is give you an opportunity to write a blog about your project. So you can write a public blog about what you built.
Okay.
With,
Okay.
yeah.
Thank you.
No problem. So there's a question about how open AI models can be secured. So so first of all, I'm not quite sure what you mean by open, but I'll give you maybe a few different ways. So one of them is that so generally speaking, most artificial intelligence models cannot be retrained dynamically. They have to be retrained explicitly. And so even if the models are open, by controlling the path of the data that you use to retrain and the process of retraining, you can usually control how it behaves later. That's one of the bigger things that you can do. If the model can be retrained dynamically, it becomes much, much harder to control. And at that point, you have to basically spend some time kind of understanding the incoming training information and see whether or not it's damaging. Any other questions? All right. So Nandala, I think if there aren't any other questions, then I think yeah, so there's a question on the Q&A. How do you handle the process time? When you say process time, do you mean the training time? So if you mean the training time, then I mean, generally speaking, depending on how complicated your model is, there are, training can take anywhere from a few minutes to tens of hours. There are things you can do. One of them is to control your tuning parameters. The other is that you can obviously find a powerful instance to run your model. So it's usually a combination of those two. So the next question is, can you explain more about MLOps? So MLOps is basically a collection of things that you need to do in order to, put your AI into production and then manage and monitor your AI. So if you're used to, for example, other programs, then you know that when you write a program, you will have to run it and people have to use it. And then, if it has bugs, you have to fix those bugs. So MLOps is really that process for machine learning. So then the next question I have is handling prediction response times. What is the best practice? Is threading a good option? That's a really, really good question. So there are different best practices depending on the type of data. So, many people, if your data can be done in batch, like in my example, for example, of bank churn, it's probably typically enough to run, through all the customers once a night or once every few days and just label them. They don't have to be in real time. Now, in real time, there are a couple of different ways. If you are connecting with, with your application through something like a REST protocol, we're probably typically looking at latencies in the order of tens of milliseconds. In that case, you can do threading. You can also do cross, like load balancing across multiple machines. Stuff like that works. If you're talking about really, really, really tight things like, you're connected to a device and it needs to get a prediction back in less than a millisecond or it will explode or something like that, then there are streaming systems out there that you can look at that have delivered, tens of microseconds kinds of latencies. If that doesn't work, then typically people build very custom solutions for themselves. So threading is a possibility. Typically machine clustering is also a possibility. So what are the machine learning, next question, what are the machine learning models that can be used for real-time predictions? So real-time predictions usually, simple machine learning models like linear regression, logistic regression, random forest, different kinds of decision trees, clustering, things like that are usually pretty effective in real time. Deep learning tends to have more of a challenge. Deep learning latencies can be 5x to 10x higher in production than machine learning. So unless you really need it, it's possible that you might want to stick with a machine learning and not a deep learning. Now, that said, there are lots of startup companies right now working on just prediction acceleration for deep learning, building everything from hardware to optimized software. So over time, one would expect that deep learning will become more real time than it is right now. It is still being used when people need it. Okay, next question. Could you please differentiate the roles between a full stack data scientist and a data scientist? Absolutely. So typically a data scientist's job is to take a problem, data, and come up with a machine learning model, for example, on their laptop, that will predict based on the data. And then they will hand that model off to engineers. A full stack data scientist is expected to be able to take that model and put it into production. So they need to know not just some data science, but they also need to know software engineering at a much greater level than a regular data scientist. So hopefully that answered your question. If that wasn't all the information, let me know and I can provide some more. But the basic thing to think about is data scientists are expected to create the model. Full stack data scientists should know the entire life cycle. Does Amazon provide, the next question is, does Amazon provide pre-trained models that we can use via API? Yes, they do. There's a number of different Amazon APIs. OCR reading is one of them. There is a product called Amazon Comprehend, because you have asked about models for understanding a sentence meaning. There's an API called Amazon Comprehend that you can try out. It provides various kinds of sentence meanings. Okay. Next question, could the big data solutions like Hadoop, Spark connect to ML solutions? So yes, you can do machine learning in both Hadoop or Spark. So they are basically alternative ways to do machine learning. Machine learning, I mean, you can also use things like Spark for initially processing the data and then give the machine learning to something else that is just focused on doing that. That's a much more common practice now. Next question, does MLOps apply only for supervised learning or for both supervised and unsupervised? The answer is it applies to both supervised and unsupervised. Okay, the next question is, does AWS provide machine learning models? Yes. So for example, one of the things that we cover in the AWS course is some of the built-in machine learning models provided by SageMaker. So, and how to use them. And yes, there is a specific format to define the training data in AWS. It's one of the things that we cover. So AWS is extremely specific about how it needs, pretty much everything. Okay. There's a next question is, what is the best ML-DL algorithm for time series prediction? So time series, I wouldn't say, I mean, it's hard to say what is the best one. There are a number of different things that are used for time series. It really depends on your use case. One of the most famous ones that is used for time series prediction is called an LSTM. So I'm going to just type that into the chat here, if I can figure out how to do that. Yeah, so LSTM for time series prediction. That is one thing you should look at. And keep in mind, LSTM is not the most advanced thing out there right now for time series, but it is probably the most generally applicable. There are approaches that are being used for natural language processing that are also starting to see benefits for time series as well. Okay, let's see what other questions are there. So could you please explain the study path we should follow to become ML engineers if you're beginners to the ML field? That's a good question. So one of the reasons why we offer this particular course is that this course is to enable software engineers who are basically, have development skills that, know how to write programs, but would like to enter the field of ML in a practical way. And so that's one of the reasons why we offer this course. Alternative methods that you can use is it's generally good to try to develop a knowledge of Python, but what I mostly recommend really is build and machine learning project. That's usually the best way to figure out how to get in. Okay, let's see what other questions are there. I'm going to go through. I'm going to just fill in the questions that I've already. Okay, so COVID messing up people's models. Can you tell us more about it? Yeah, so the question is, what is the relationship between COVID and machine learning? So basically, the central idea is that COVID has created a really, really big change in the way that many business processes of the world operate. Everything from how food gets routed between farms and, restaurants, to how people's purchasing patterns are and what those purchasing patterns mean. And so because of that, it has essentially previous, learnings that AIs may have learned about shifts in patterns and their implications pretty much become invalid. So for example, if an AI believed that if I hadn't, not been to a grocery store in the last 2 weeks, it means that I've chosen another grocery store. That probably would have been true before COVID. But these days, that's not the reason why I haven't been to the grocery store in 2 weeks. It has nothing to do with my intentions of future purchases in the grocery store. So stuff like that, where basically there's been such a massive change that in the past, that massive change might have meant I'm leaving a business, or I've changed, or I've left the country or something, whereas now it means nothing but COVID. So, let's see. Okay, so those I think are possibly, Nandula, let me know if I missed any questions. I think I answered a bunch of them. So. Here we go. There's another one. What are the best options to serve ML models in production? Yes, very good question. So most common one that is useful for a very wide range of use cases is what we call REST model serving. So the idea is that you run a program in the cloud, it contains your model, it's able to get new questions and serve out predictions, and it is essentially a running microservice. And so we teach you how to build that kind of microservice inside the AWS class. You can also build it using things like Amazon serverless functions and Lambdas. But the basic idea is you send an HTTP request to the AI, it sends back a prediction. It's good for most general purpose use cases. Where you might need something different is if you need extremely low latency predictions, in which case you can use like a streaming service. So example would be something like Kafka or Flink or things like that. So that's one possibility. And obviously, if you're not time sensitive, batch is a perfectly fine way to do it too. Batch means that you schedule a process maybe once a night and it just goes through all of your questions and generates all your predictions. So that's another one. Okay, so one more question. In Sri Lanka, are there any initiatives for legislation of AI and ML models? I'm not aware of any in Sri Lanka, but it's a good question. What I have found, however, is that because most industries right now are, international, that laws pretty much anywhere in the world have a tendency to affect everywhere else. So, for example, the laws in Europe have already affected, North American companies. So in that sense, it doesn't have to necessarily be a local law to affect you. Okay. Then there is a next question, which is, hold on a second. Okay, so there's a whole bunch of questions. Give me a second here. So the next question is, according to your experience, what is the best IDE that you can use? So to develop an ML model. So the most common environment that people use to develop machine learning is a Jupyter notebook. So I will type that in. It's called Jupyter notebook. Okay, and it's basically a way to run interactive Python code. So notebooks are generally, so first of all, the most common language that people use is Python. So any Python IDE will in the end do. The nice thing about Jupyter notebooks is that they can be interactive, and they're not the only interactive mechanism out there, but they can also be easily connected to the outside world. So then the next question is, do we create a custom model in the course or do we train in the pre-built model? You do both. So the pre-built models are covered, but we also cover how you create a custom model and you bring it in using a Docker container. So yeah, both are covered. Next question is, can we build an ML model and just deploy in AWS? Yes. Just is a little bit tricky. It's harder than it sounds, but yes, you can absolutely do that. You can build so the way that AWS works is you can build an ML model that is not a built-in. You have to build it into a Docker container, and then you have to hand the Docker container over to AWS and teach the AWS how to deploy it. So it can be done, and that's how you do it. Next question is, how do you explain how, can you explain how a UX engineer can get into ML AI data flow without programming? Ooh, very interesting question. So absolutely. So one of the newer trends in machine learning is that you don't have, it's really called the low code or the no code movement. And the basic idea is that a lot of the programming that you need to do in order to do machine learning can be automated. And so unless you really, really want to do the programming, there isn't a reason why you must do it. So in Amazon, for example, every single thing that you can do with a program can be done with a UI. And so, and that's for ease, because it just, just because you can program doesn't mean you have to, if the programming that you're running is pretty much can be auto-generated anyway. So yeah, so it's certainly possible to do ML and AI without programming. Almost every major tool out there right now has a low code or a no code kind of interface. So that's the answer to that question. So let me scan and see if there's any other questions. Okay, I think I caught all of them. I'm going to wait for another minute and see if there's anything. Yes, my mistake, by the way, guys. I misspelled Jupiter when I typed it in. It's Jupiter with a, I think my autocorrect may have fixed it for me, unfortunately. It's Jupiter with a Y, not Jupiter as in the planet. So if you ever need to Google for that. Thank you. I'm just going through to see if I have. Okay. I think I've gotten through maybe all the questions. Yes, I did. Okay. So I think we have all the questions, Nandula. So in that case, thank you very much, everybody. Hope this was helpful. And you have our email address if you want to contact us for any future questions. Thank you.